Welcome back to part 2 of service capacities for apartments and similar buildings. We're now going to look at how we're going to size the feeders for all the loads that are outside of the dwelling units. Our house panel or a public panel is designed to take any loads that are not specifically part of one of the suites or our dwelling areas. So this would include things such as alarm systems, fire alarms, laundry units, boiler systems, heating and cooling in the common areas, and any receptacles and lighting that are found in any hallways or entrances. Rule 8.202 sub rule 4 states that for any loads not found within the dwelling unit, the feeder shall be sized on 100% of those loads. So we need to take a look at how big those loads are, and then we need to be able to choose a feeder that will be able to handle all those loads being run at the exact same time without failure. Within our apartment building, we have 3 5-kilowatt dryers, 3 2.8 kilowatt washing machines, 2 2-kilowatt heaters, and the 2800 watts of additional loads. The 2800 watts of additional load would include things such as the fire alarm panel, the security system, the boiler controls, and so on and so forth. So it's all the little things that we don't account for specifically, but we can total them up to get a value. Once we add all these together at 100%, we get a total wattage of 29,900 watts. We're going to take this wattage, divide it by our highest voltage, and keep in mind if we are on a 3-phase system that has a 120/208 service, we would be dividing it by 208 volts. But in this case, we have a 120/240 volt service, so we will divide this by 240 volts. Our ampacity ends up being 124 amps, and this is the value we take over to table 2. According to table 2, we need to have a 1 gauge conductor rated at 130 amps, which means that we can have up to a 150 amp overcurrent device for this feeder. Let's go back to our service drawing and add these values onto it as well. Our public panel or our house panel will have a number 1 gauge conductor with a 150 amp maximum fuse. The next feeder type that we're going to look at is for our parking lot panels. Within our parking lot panels, we have specific loads such as for block heaters as well as for EV chargers. So we need to know what the rules are for those two particular instances. When it comes to our block heater receptacles, we have a couple of choices, but we need to know some definitions first. First, we need to know, according to Rule 8400, whether or not the receptacles that will be used for the block heaters are either controlled or restricted. So the definitions for those are also within 8400. A controlled receptacle, for example, is any receptacle that is automatically modulated, so it's only on for a certain amount of time. Generally speaking, they're going to be turning the receptacle on and off every half cycle. This means that that receptacle is only ever powered for half the amount of time, which means that we can have it on for lower wattage value. The term restricted refers to any receptacle that has been designated as only for block heating. And basically all we have to do is put on a little label by the receptacle saying for only block heater purposes, and that makes that a restricted receptacle. If it's neither controlled nor restricted, then we have to assume that it can be used for higher than average wattage values. Therefore, we have to put a larger wattage value toward our feeder. When it comes to our EV chargers, we're going to be looking at section 68 as well as table 38 to determine what the rules are according to those. Let's take a bit of a closer look at Rule 8400, which has to do with our block heater receptacles. We do have an option of installing either a 15 amp or a 20 amp receptacle, depending on what our customers asked for. However, the wattage value of those receptacles are going to change depending on how many receptacles you have within your parking lot. Rule 8400 sub rule 3 deals with receptacles that are not controlled or restricted. So we have no limitations on these receptacles whatsoever. Therefore, we need to follow the wattage ratings as per this chart. If we are dealing with the receptacles that are controlled or restricted, now we look at Rule 8400 sub rule number 4. And you'll notice that since these are controlled or restricted values, our wattage value per receptacle is also going to be less. When it comes to electric vehicle chargers, we need to know what the size rating of each charger is, and we need to know how many chargers are going to be on site. Then we can use table 38 in order to determine where our values sit. Let's do a couple of examples for EV chargers so we understand how the table 38 works. Our first example is going to be 10 chargers, each rated at 2400 watts. Within my chart, all my chargers are broken up into groups of 4. When I look at my wattage values, if the wattage value of my charger does not match one of the wattage values inside my chart, I must go up to the next higher wattage value. Since my 2400 watts does not match any other value, the next one higher is going to be 4000 watts, and I'm going to use the demand factor for 4000 watts for all of these chargers. I start by looking at the first group of 4. The first group of 4 at 4000 watts has a demand factor of 100%. So I'm going to take my 4 chargers, multiply them by their wattage value, and then multiply them by the demand factor. So I have 4 times 2400 times 100%. I'm going to do the exact same thing for the second group of 4. I'm going to take 4 chargers, multiply them by 2400, and the demand factor is still 100%, so I'm going to multiply those by 100% as well. For the first 2 groups of 4, we have a demand factor of 9600 watts each. I still have 2 chargers left over, so that means I need to go into the next group. The next group has the demand factor of 90%. Therefore, I'm going to take my 2 remaining chargers, multiply them by their wattages, which is 2400 watts, and then multiply them by the demand factor, which is 90%. I will get a demand for this group of 4320 watts. My next step is to add those 3 values together. I will get a total demand for these 10 chargers as 23,520 watts. Our next example is taking 15 chargers, each rated at 7200 watts. Now, the same thing as I did in the first example, if my wattage does not match one of the values on the chart, I need to go to the next higher value, which is going to be my 8000 watt value. My first 4 chargers are going to be at 100% demand factor according to the 8000 watt row. Therefore, I'm going to take my chargers, multiply them by the wattage, and then multiply them by the demand factor. So I have 4 chargers at 7200 watts. At 100% means that that first group of 4 has a value of 28,800 watts. My second group of 4 now has a demand factor of 90%. I will do the same math, where I will take my number of chargers, 4, multiply it by the wattage, 7200, but now I multiply it by 90% instead. So the demand for the second 4 will be less than the demand for the first 4. I continue down my chart, doing the same thing for my next group. However, now my demand changes again to 80%. So 4 chargers multiplied by 7200 watts multiplied by 80% will give me demand for this set of 4. I still have 3 charges left over, so this pushes me to the next category. Underneath the next category, I'm still dealing with an 80% demand, so I will take my remaining 3 chargers, multiply by the 7200 watt value, and then multiply it by 80%. After I've done all 4 of these columns, I can add up those values to get a total of 95,040 watts for these 15 chargers. If you happen to have multiple different sizes of chargers on the same building, you can still use the same method. However, you always need to use the largest chargers first. For example, if I did have 7200 watt chargers mixed in with 2400 watt chargers, I would follow the same pattern, but I would be taking into my 7200 watt chargers at the demand value on the chart. Let's go back to our apartment suite example. In our parking lot panel, we are going to have 11 controlled 15 amp receptacles and 4 EV receptacles, but we don't know what the size is. For the controlled 15 amp receptacles, we have to look at Rule 8/400 sub Rule 4, which states that I'm going to use a value of 650 watts per receptacle up to the first 30. I will take 11 stalls multiplied by 650 watts to give me a total demand of 7,150 watts for my car heaters. In order to do my EV receptacles, since I don't know what the demand is, I need to go to Rule 86306. Rule 86306 states that I need to use a 125 volt receptacle rated at 20 amps. So my multiplier is going to be 120 volts times 20 amps to give me a 2400 watt receptacle. According to code, if we don't know what it is, we will use these 2 values and we will use 2400 watts as our starting point. When we turn to table 38, we find out that we have a 100% demand for these 4 receptacles, so I can take 4 times 2400 times 100%, which gives me a value of 9600 watts. For my parking lot demand, I take everything at 100%, therefore I'm going to take 100% of the heating receptacles and 100% of my EV load and put them together. My total parking lot panel demand is going to be 16,750 watts. I will divide that by 240 volts, which is the highest voltage in our system, to get a total ampacity of 69.79 amps. Remember, if your building has a 120 208 volt supply, you must use a 208 volt divisor here. Since our building is a 120 240 volt supply, this is why I use the 240 volt divisor instead. When I take my 69 amps and I go to table 2, I find I need to use a number 4 gauge conductor. And table 13 tells me the maximum fuse size I can put on that 4 gauge conductor is a 90 amp fuse. We can now go back to our service diagram and put this information in. My parking lot feeder will be a 4 gauge conductor, and my overcurrent device is going to be a 90 amp fuse or breaker. Now we've gone through all the different steps that we needed in order to determine what our different demand loads are going to be on any loads not inside the dwelling units. So these are going to be our public loads or our house panel loads, as well as our parking lot loads. One thing I want you to remember is that our parking lot loads can actually be inside our house panel or even be inside the suite panels, but we would calculate it all out the same way. We still need to pay attention to Rule 8400, and we still need to pay attention to Table 38. When you're ready, go on to the next video.